In the previous video, you just had vectors that were at right angles, or you had one vector and you broke it up into its components. Now we're going to take a few vectors that are in different directions, and maybe one of the vectors is off at an angle, and this will be a little bit more complicated, but it still follows the information that you covered in the previous video. So here are your basic steps. We're going to go through them one at a time on the future slides, but you're going to make a scale drawing. You're going to break up your vectors into their horizontal and vertical components. You have to determine which signs are positive and which are negative. You're going to add your x's and add your y's, and then you're going to use the Pythagorean theorem to find your resultant and the inverse tangent to find your angle. So here we have a problem. We have a person who walked 30 meters east, 15 meters at 25 degrees south of west, and then 40 meters north. So here's our 30 meters east, goes north, south, east, west, north, south, east, west. One of the ways to remember where the west is if you look at a map of the United States. Okay, California is over on the west coast. That's how I always remember it. There's your west, and then we're going to go 25 degrees for 15 meters, 25 degrees south of west. So this one should be half as long as our 30 meter. So 30 meters east, and then this is 15 meters, and it's at 25 degrees, so it's below the horizontal, and it's south. Here's west. We're going south of west. And then we have our last vector, which is 40 meters north. Okay, so we're going to go straight up north. And then our resultant for our picture, our resultant is going to be, so our resultant begins where we started and ends where we ended. So this is our resultant, and that's what we're looking for, is that resultant. Okay, so now we're going to break them up into their horizontal and vertical components. Our 30 meter vector east goes straight horizontally, so it's going perfectly horizontally. So it is all horizontal, that's the 30 meters, and none of it is vertical. Our second vector is 15 meters long at 25 degrees south of west. So since that one's diagonal, we need to break it up into its horizontal and vertical components. And the horizontal is always going to be cosine, and your vertical is always going to be sine. So we go 15 cosine 25, and then we do 15 sine 25 to get the x and y components of our 15 meter long vector. And then our 40 meter long vector, that's going straight up. So none of it is horizontal. It's all vertical. So none of it is horizontal, and all 40 of it is vertical. Okay, then we need to determine our signs. And you can be a slave to the quadratic or to the Cartesian plane. That's perfectly fine. That's this down here. And the first quadrant, everything's positive. Second quadrant, the x is negative, the y is positive. Third quadrant, negative, negative. And then the fourth quadrant, it's positive x and a negative y. And you could do that, and that is never wrong. Sometimes it's not necessary, but it's never wrong. So using that, since our vector is going east, okay, east is this way, so it's in the positive x direction, so we gave it a positive sign. And y doesn't have to be positive or negative because it's 0. This second one is south and west. So it's going, do you see here, it's going down towards the third quadrant, south and west. So both its x and its y are going to be negative. It is possible to have your x negative and your y positive, because then if the x is negative and your y is positive, that means it's going up in this direction, so it's going up towards the it's going up into the second quadrant. And then our last one is north, due north, straight up. So that's in the positive y direction. So we give our y a positive sign. So then we take our handy dandy calculator and we add up all of our x's going down and all of our y's going down. Make sure you put in the negatives. Make sure your calculator is in degrees. Okay, we're always going to be using degrees in physics, so make sure you're always in degrees. So when we add the x's, we get positive 16.4 meters, and since it's positive, the positive x direction is to the east, and then our y's comes out to 33.7 meters, also positive, and since it's positive, the positive y direction is up, so that's going to be north. So based on our answers of the previous slide, we have 16.4 meters going to the east, 33.7 meters going to the north, and we want to find our resultant. Hey, guess what? This is a right triangle. So right triangles, we can use a squared plus b squared equals c squared. So 16.4 squared plus 33.7 squared is equal to our resultant squared. This is our resultant. And so that comes out to, our resultant comes out to 37.5 meters. Okay, we're not done. So that's our magnitude. Our magnitude is 37.5 meters. That's how far he went as the crow flies. So that's the straight line distance. But we also need to give an angle. Okay, we have to give a direction, and our direction includes the angle. We already know that it's east and north, so this would be northeast. We're always going to put the up-down direction first, and we need to get this angle. So do you see here we have the adjacent and we have the opposite, so we're going to use the inverse tangent. Inverse tangent, and it's just like slope, you're going to do your y over your x. So 33.7 divided by 16.4, and that comes out to 64 degrees north of east, or northeast. And so our answer is 37.5 meters at 67.4 degrees north of east. That means this angle right here is 64 degrees. Basically, we know it, we did it right, because our algebraic answer, that 37.5 meters, so at 37.5 meters that we had, 37.5 meters at 64 degrees should match what our drawing said. And notice our drawing had our vector going to the north and east at the very beginning. And if we were to actually measure this length with a ruler, it should be in scale, so that 37 meters should match the scale. So you do the drawing to see if your math is on par. They should match, and that's how you know you did it right. So that's it for now. It's time to practice, and I will see you tomorrow. Good luck, ladies, and make it a great day.